Chapter 6, Section 1, Polygons. A polygon is a plane figure. Remember, plane is going to be that flat surface. So it's going to be a flat figure that is made up of at least 3 segments or sides. Remember, when we're talking about a segment, that is part of a line. So when we say 3 segments, that means that they have to be straight, that meet at their endpoints to form vertices. So a polygon is going to be a flat figure that is made up of at least 3 straight sides that meet at their endpoints. So they can't cross one of the segments, or sides cannot continue past where 2 sides meet. This example says, identify the figures that are not polygons, explain. If you look at figure A has all straight sides, and all of the sides are meeting at each other's endpoints. So A would be a polygon. If you look at B though, notice B is very similar to A, but it's missing one of those segments that connects 2 of the other segments. Because all of the segments do not have a connect to another segment at their end point, B is not a polygon. It is not enclosed. 2 sides only meet one other side instead of 2 other sides. Next, if you look at C, we have all straight sides. All of them are segments. However, notice that these segments are crossing each other and extending past where the 2 meet. Because C, the segments do not end at the vertices, C is not a polygon, and the reason is the sides do not end at the vertices. But if you look at D, which is very similar to C, that would be a polygon because all of the sides are ending at the vertices. Convex versus a concave polygon. A convex polygon is one that if you extend the segments or sides, they will be on the exterior of the polygon. Concave, or another way to say concave is non-convex, is if you extend the segments or sides, one or more will be in the interior of the polygon. Convex and concave, a way to think about this, if you look at concave, cave is something that is cut into a mountain. So if you just think of a cave in nature or outside, a cave is something that you're going to go into. It's going to cut into a mountain or a hill. That's going to be the same idea for the shape, and I have examples on the next slide. So it says identify the polygon and state whether it is convex or concave. We haven't talked about identifying the polygon yet. Identifying the polygon is going to be using those words that you've learned before that classifies it a polygon based on the number of sides. So if it's a 3-sided polygon, it's a triangle. If it's a 4-sided polygon, it's a quadrilateral because quad means 4. If it's 5-sided, it's a pentagon. 6-sided is a hexagon. 7-sided is a heptagon. And 8-sided is an octagon. I believe you have to know through 12, but I believe there's a chart in your book that will help you with that. And like I said, those are not, those shouldn't be new. You should have heard those basically from elementary school. So identifying the polygon, that's what it means. Triangle, quadrilateral, pentagon, so on. It says state whether it's convex or concave. If you look at A has 4 sides, so it would be a quadrilateral. And A, if you look at all of those sides, if you extended them, they're all going to be on the exterior of the polygon. So this A would be a quadrilateral, and it is convex. There's nothing that's cutting into the shape. If you extended all of the sides, then they would be on the exterior of your polygon. If you look at example B, first thing we need to do is identify the polygon. If you count the number of sides on this polygon, it has 5 sides, so it is a pentagon. If you look at this shape though, if you extend some of those sides, they are going to be on the interior of the polygon. Notice also that the top 2 sides are going into, or they're cutting out a piece of that shape. So anytime you have something that's going into the shape, we're going to call that concave. A polygon is considered equilateral if all of its sides are congruent. A polygon is considered equiangular if all of its interior angles are congruent. And a polygon is going to be called regular if it is both. So equilateral if it has congruent sides, equiangular if it has congruent angles, but if it is both equilateral and equiangular, we're going to call the polygon regular. This example says, decide whether the polygon is regular. If you first look at A, notice it's a pentagon and all 5 of the sides are congruent because they all have the 1 tick mark. But if you look at the angles, so we can say that it is equilateral. If you look at the angles though, we have 2 right angles on the bottom. Then the next angles on top of those would be 2 obtuse angles, and then we have an acute angle at the very top. So this polygon, or this pentagon, is not regular. It is equilateral, but not equiangular. If you look at example B, notice we can automatically say that it is not regular because we have 2 sets of congruent sides, but they're not congruent to each other. So the top and the bottom sides and the sides on the left and the right are congruent to each other, but they're not congruent, like the top and bottom sides are not congruent to the left and the right sides. So this is not going to be a regular polygon because it is not equilateral. But if you notice, it is equiangular because all 4 of the angles are right angles. So it is equiangular but not equilateral, so we cannot say that it's regular. The next example says, state whether the figure is a polygon. If it is, state whether it is convex or concave. If it is not a polygon, explain why not. If you notice example A, we have a shape that has 2 curved sides on the bottom. Well, if you think back to our definition of polygon, a polygon has to have 3 or more segments or straight sides. So because A has 2 curved sides, we say that A is not a polygon because 2 sides are not segments or they are curved. If you look at B, in this case we do have straight sides that are meeting at the vertices. They're not extending past the vertices and it is enclosed. So in this case it is a polygon. Then we have to decide if this is convex or concave. In this case, because on those sides we're going into this shape, it is going to be a concave. So yes, it is concave, and it's an octagon. It's an octagon because it has 8 sides. Interior angles of a quadrilateral theorem says that the sum of the interior angles of a quadrilateral is 360 degrees. So when you add the interior angles of a quadrilateral together, and this is going to be true for any quadrilateral, meaning any 4-sided shape, the sum of those angles is 360 degrees. This example says find the measure of angle F, the measure of angle G, and the measure of angle H. Notice that they've given us that the measure of angle E is 55 degrees And they've also told us that angle E and angle G are congruent because they each have one arc in the angle. So because angle E is 55 degrees and angle G is congruent to angle E, we can say that angle G is 55 degrees. Now, we do not know the measure of angle H and the measure of angle F, but we do know that they are also congruent because they are both x degrees. Because these are both x degrees, and I know that the sum of all four angles of a quadrilateral are 360 degrees, I can say 55 plus 55, which is the measure of angle E and angle G, plus x, which is the measure of angle H and the measure of angle F, equals 360. I'm going to go ahead and combine my like terms, and I'm going to say that 110 plus 2x equals 360. When you subtract 110 from both sides, you get 2x equals 250. Divide both sides by 2, and you find that x equals 125. So, because x equals 125, we know that the measure of angle H is 125 degrees, and the measure of angle F is also 125 degrees. The next example says find the measure of angle K, the measure of angle L, and the measure of angle M is quadrilateral JKLM regular. Remember, to be regular, you have to have equal angles and equal sides, or congruent angles and congruent sides. We do know that they have congruent sides because each side has one tick mark, so telling us that they are congruent. To find the measure of the unknown angles, we need to add all of the angles together and set it equal to 360. So I'm going to say 80 plus x plus x minus 20 equals 360. I'm going to combine my like terms, and I have 3x plus 60 equals 360. Subtract 60 from both sides, you get 3x equals 300, so x equals 100. Now, to go ahead and find the measure of the missing angles, I know that M and K are both going to be 100 degrees, and I know that L is going to be 100 minus 20, or 80 degrees. So I'm going to go ahead and label those. Those were just x, so I'm just going to say that they're each 100 degrees, and when I do 100 minus 20, I get 80 degrees. It says, is quadrilateral JKLM regular? The answer to that question would be no, it is not regular. It is equilateral, but it is not equal angular. Today's assignment is on page 325. It's numbers 12 through 20 even, 21 through 22, 24 through 38 even, and 42 through 52.